All right, so day one, final exam review. First question says graph this function, okay? Now, I've left this function in a specific form. It's going to be the same way on your final exam. Like I said, I'm copying these things basically from the final. I'm just changing stuff around. So let me just remind you of a couple of things, okay? So f of x is equal to, so we're going to have a over x minus b plus c. Now the bottom part's always supposed to be a minus from x minus b. It's not supposed to be x plus b according to the general formula. If it says plus, that means that the b value must be negative, okay? But here's what you guys have to remember, okay? The b value moves left and right, okay? It tells you which way to go. A positive b moves, do you guys know? It's going to go left. A negative b moves to the right, okay? The c value, this moves up or down, okay? And remember, like I'm telling you guys right now, when we're taking notes, if I'm moving a little quick, stop taking notes, observe what I'm doing, because you guys can go back tonight and fill in any blanks. You're like, oh, I remember he wrote a formula for this. Go back and write it later. It's not a big deal, right? You don't have to write every single thing I do. Just write down the stuff that's important to you, right? So it'll be there later. Like I said, even if you just want to sit there and watch right now, it just means you got to copy them later on, maybe if you need to. But still, if you want to do that, that's fine. So C moves up and down. A plus C goes up. A minus C goes down. Okay, so a plus C moves up. A minus C moves down. Okay. Now the other question is, well, what do these graphs look like? Well, these are called reciprocal functions, okay? And reciprocal functions tend to look like this. Now, if a is negative, it'll flip the function, okay? But I gave you a problem like this, and it's not negative, which means the one on the test is not going to be negative. If there's one that comes out later that's negative, I'll show it to you, okay? But so far, I've looked at 22 questions. None of them, well, there's only been one of these so far, and it wasn't a negative function. So it's going to look something like that, okay? Now, one more thing for you guys to know about these things. Your C value is called your horizontal asymptote. That's like a horizontal line you cannot pass. And your B value is called your vertical asymptote. So there's a lot of information with this problem. Vertical asymptote. So A-S-Y-M-P and then T-O-T-E if you want to write the whole word. But vertical asymptote, horizontal asymptote. I usually write V-A-H-A to summarize it, right? To just paraphrase it. And so, okay, so here's how it's going to be done. All right. Remember, this is all multiple choice. So you don't have to be able to graph this thing perfectly. You just got to be able to find the one that looks like it's the right answer, right? So right here we have 3 over x minus 2 plus 1. Now, I like starting with the outside number first, the plus 1. That's my horizontal asymptote. So I'm going to have a horizontal asymptote at positive 1. So there we go. This is my horizontal asymptote. Okay? If you want, I'll even label it HA. Okay? Horizontal asymptote. Now my vertical asymptote is going to be where? It says x minus 2. Where am I going to put the vertical one at? At minus 2 or plus 2? Plus 2, right? Because this has to move to the right side, right? Has to move to the right side twice. So here we go. By the way, if this problem is scaring you because you're like, man, this is number 1 and we're doing this, this one's kind of a tough problem, but you know, there's a lot of different types. But yeah, one of these will show up. All right. Once you're done with this, guys, now you just have to sketch. Okay? So, this is what you're going to do. You're just going to grab your graph and go really, really close to the end. Come down this way. And then do the same on the other side, and you're done. Okay? You don't have to do any points or anything like that. Usually it's wise to do points, but since you have a multiple choice test, one of them is going to look like this. So you're going to say that's it, right? The other one might be flipped over. The other one might be moved over to the left, maybe moved too high up or too low, right? You just got to be able to say, okay, it's supposed to look like this. Which one of these looks like that? Okay? So you don't have to do a bunch of work. You just got to know those definitions. There really is no work required for this problem. You're just kind of looking. You're going to draw your horizontal asymptote, your vertical asymptote, and then just kind of draw your graph the way it's supposed to look. Okay? And then from there, pick the right answer. All right? So that's the first question. I know that one's, we started off with a tough one, but that's the way it is on the test. And you may get this one first, you may not. There's 55 questions, so 1 out of 55 chance you're going to start with this one. Before I move on, any questions on this one? All right. Remember, there's videos online. These are called reciprocal functions. Look on Google Classroom. They're there. Okay. If you need a review, or if you don't want to hear me, then just type it in on YouTube. There's tons of people. I recommend someone with an English accent because it always sounds like they're right. So, all right, number 2. If y varies inversely as x, and if x equals 12 when y equals 4, find y when x equals 6. Now, these are really easy problems. The hard part about it is, do you remember the formula? Okay? Do you remember the formula? So this is an inverse variation, and if you look towards the bottom, you can see that there's going to be a direct variation problem as well. Okay? But inverse variation has its own formula. Direct variation has its own formula. So you got to make sure that you know them. So let me write them down for you guys. For inverse variation, the formula is this: xy equals k. And if you remember, anytime you do these variation problems, you got to write the formula 2 times. Okay? So xy equals to k. The first time you're going to use the first piece of information they give us. Okay? This right here. They say if x equals 12 when y equals 4. That piece of information helps me figure out the k value. That's my initial job, figure out what k is. So I'm going to get the information they gave me. X is 12 and y is 4. And I'm going to put 12 times 4 equals to k. So k is 48. All right, so now that I got my k value, I get to plug that in to this part. Okay, so I know that it's going to equal to 48. The question is, well, what other number do I plug in? Well, they give us that. They say find y when x is 6. So I know what x has to be. X has to be 6. So 6y. So if I divide both sides by 6, y has to equal to 8. And I'm done. These are easy problems, but you better know the formula or else good luck. Okay? You got to know the formula. The formula is not terrible, but if you're like, yeah, but I may not remember it, well then right now you're making notes. Write down inverse variation formula, right, on your cheat sheet. Like this, you're writing stuff down, right? Like you need this, or maybe you don't need it. All right, question number 3. If y varies directly as x, so this is direct variation, not inverse variation. So if y varies directly as x, and x equals 10 when y equals 5, find y when x equals 20. Now remember, direct variation means that when one of the variables goes up, the other variable goes up too. They both either go up or they both go down together. They vary directly. One does something, the other one does the same thing. Inverse, the one we just did, when one goes up, the other goes down. Or if one goes, or if the other one goes down, the other one goes up, right? They do the opposite. direct, they're going to do the same thing. So right here I see x is 10, y is 5. Find out what y is when x is 20. I notice x went up. That means y is going to be bigger. Okay? So direct variation, they both do the same thing, both up or both down. Okay? So here we go. Your formula for direct variation looks like this. Y over x equals k. And remember, you always write it twice. So look at the first piece of information to figure out what you're doing. Okay, so the first piece of information says when x is 10, x is 10 when y is 5, sorry. So let's put those numbers in. X is 10 when y is 5. So let me put that in here. X is 10 when y is 5. That means that k is half. So now I'm going to put the half value on the right side. And then I'm going to look at the rest of my problem, and it says, find y when x equals to 20. So find y when x equals to 20. So you can do cross multiplication if you want, or if you want, you can also just multiply 20 times half. Just move the 20 over. Well, half of 20 is 10. That means y is equal to 10. And that would be your answer for this problem. Again, you'll be able to use calculators and stuff, so don't feel like, man, I got to do that in my head. Like, no, you have calculators available to you. Okay? Again, not a hard problem. It's just you need to know the formula. Okay? If you know the formula, you know you got to write it down twice. First find k, the other time find whatever else they need. It's not a tough problem. It's just you need the formula. So make sure you guys write those down if you don't remember them. Any questions on 2 or 3? All right, question 4. Just solve. They don't tell you how, but it just says solve. I mean, there is a big hint what you need to do. What do you notice? What sticks out for these? Like if you look at this problem, like what are the things that kind of catch your eye right away? I think I heard someone say it. You guys think the square roots look kind of obvious, right? How do you get rid of square roots? You square. So what you're going to want to do is square. Okay? Get rid of those square roots. So I am going to square both sides. And that's not good. So I just restarted my thing too. Hold on one second. All right, sorry about that. So yeah, we're going to square both sides. Okay? Now in doing so, the square roots disappear. So this is just x over 2 equals to 30 minus x. Okay? If I got to solve for x, I got to get rid of that division by 2. So let me multiply the 2 over to this side. But remember, since there's 2 terms on the right side, I have to distribute. Okay? So it's going to be x equal to 60 minus 2x. Because 2 times 30 is 60. 2 times negative x is negative 2x. I'm going to add 2x to both sides. Okay, so adding 2x to both sides gives me 3x equals to 60. And when I divide both sides by 3, what's x equal to? 20, right? We got our 20. So there you go. There's your answer. Not a hard problem. It looks difficult to start. But if you just square both sides, you fix it. Okay? I noticed that the first day has a lot of like square root problems, not square root, but factoring and solving type problems. So, are we okay with number 4? All right, number 5. This one they give you a big hint, and it's going to be the same way on the test, so I highlighted it here. The instructions literally say solve by taking square roots. Okay? Now, they don't mean to do it immediately, but you're going to solve eventually by taking square roots. So I'll show you what they mean by that. So they do tell you what you're trying to go for eventually. You're going to take some square roots. So we got 2x squared minus 4 equals to 16. In order to solve, we always want to try to get our variable by itself, right? So let's do that. Let's add 4 to both sides. So that's 2x squared is equal to 20. We'll divide both sides by 2. If I divide both sides by 2, I get x squared equal to 10. Okay? And now is when I'm going to take square roots. Okay? I'm going to take square roots at this point. So, I want to get rid of the x squared, so I'm going to take a square root of both sides. But here's where you guys got to remember. Anytime you take a square root of a number, there's always two answers. Plus or minus, okay, the square root of 10. Can I simplify the square root of 10? Can I reduce it in any way? Because what are the factors of 10? 1 and 10, which doesn't help. 2 and 5, but 2 and 5 don't have nice square roots. So that's it. So there's no nice square roots. This is my answer. My two solutions, positive radical 10 and negative radical 10. Again, not a hard problem. You just got to know how to do it. So if you know how to do these, great. Don't study them. You know, you're good. But if you're like, yeah, I don't remember doing that, practice these, right? All right, moving into the factoring portion. Now remember, whenever you have to solve a problem, especially when you're having to solve it by factoring, you got to set it equal to 0. Okay, you don't want it to say something equals 10, something equals 5. It has to say something equal to 0, and then you can start factoring. Okay, sometimes you're going to have numbers in front of the x squared term. Sometimes you won't. All right, so this is one where there's a number in front of the squared term. So that means at the end, when you do your x method, you're going to have to divide. Unless you don't do the x method, in which case you do it a different way. But if you're doing the x method, you'll divide. So what I'm going to do is I'm going to subtract 1 on both sides first. Okay, so this gives me 2x squared plus x minus 1 equals to 0. And now I'm going to start factoring. So hopefully you guys are good at this part by now. Okay, the factoring part, I'm hoping isn't the part that's going to get you. But remember, the top, you're going to multiply a times c. That's 2 times negative 1, right? I'll put it right here. Whoops, not that. A is equal to 2, b is equal to negative 1, and c is equal to, I'm sorry, positive 1. And then c is equal to negative 1. So a times c is negative 2, b is 1. I got to think of two numbers that multiply to negative 2 that add up to a positive 1. So a positive 2 and a negative 1. Okay? But I don't want to circle these. Usually I do this. I'm like, okay, I'm done. Let's move on, right? But I have an a term that's not a 1, which means I got to divide by my a term on my answers. So I'm going to divide this. Let me change the color here. By 2. Now the negative half cannot be simplified anymore. So this one I am going to circle. But the 2 over 2, that becomes a 1. So this is equal to a positive 1. And that's going to get circled. So those are my factors. So let me go ahead and write those out. X plus 1, right? Because there's a plus 1 right here. X minus half equal to 0. The minus half is right there. Okay, now remember, they do want you to move that 2 in the denominator over, right? Because you're not supposed to have factors with fractions. So they want you to do this. I had a student ask me the other day, like, do we have to do that when we're solving? Because aren't we just going to divide again later on? And I said, yeah, you don't have to do it. But usually if you do any type of state test, they always do that. So it's beneficial for you to do the same thing. So all right, now that I have it there, I can solve. You make two small little equations, okay? So x plus 1 equals 0. 2x minus 1 equals 0. We subtract by 1 on both sides. So right here we get x equal to negative 1. So here's one answer. If I add 1, I get 2x equals 1, and then I divide by 2. I get x equal to half. People also notice, they're like, wait a minute, weren't those the factors that you used up here? Yeah, they are. When you do math enough, you start recognizing that sometimes you solve for stuff way before you intended to solve for. Okay? But yeah, they do show up on your X method. So, just something for you to notice. Any questions on number 6? This is more on the more difficult factoring type problems, right? Because there's an A term in front that's not a 1. All right, moving on. Solve. Now they don't tell us how to solve, so it's up to us. I mean, we could move the 90 over to the left side, set it equal to 0, and try to do that. Or maybe we just divide both sides by 10. I mean, for me, I would first divide by 10. Okay, let's get rid of that number in front of it. Then if I have to move stuff around, I'll do it. But let's divide by 10. So I get x squared equals to 9. If I take a square root of both sides, does 9 have a nice square root? Yeah, it does, right? Even if it didn't, who cares? Do it anyway. We just did that on number 5, right? We had an x squared, and we took a square root, and the answer was plus or minus radical 10. It didn't simplify to something easy, but it was the answer. So I'm going to do the same thing here. Take a square root. So x will be plus or minus 3. And there you go. Yes, there's a question just like this. Maybe not a 10 and a 90, but it might be a 2 and a 20 or a 4 and an 8 or something like that. But it's going to be the same difficulty. Okay, so are we okay with this one? Just division, square root, we're good. We got 4 more to go. So we're going to factor this one. So notice we're not solving, just factor. Just factor. Now, before you do any type of X method, what's the first step you're supposed to take? Because I can start with the X method immediately, but then I'm going to run into a little tiny issue. But what should you do anytime they tell you to factor? What's the first thing you look for? The like terms, right? What number do they all share? A 2. So let's take a 2 out. That'll make it easier when we do our factoring. This will be 2x squared plus 5x plus 3. Remember, we're going to focus on this, but we do not want to forget this 2 because it's going to be part of the answer at the end. Okay? But now I just got to factor 2x squared plus 5x plus 3. Okay, so let's factor that. And if you're wondering, well, what would have been the difference? If I would have factored the top one, the top number would have been a 30. I'm sorry, not a 30, a 24. If I would have done 4x squared plus 10x plus 6, 4 times 6 is 24. Then you got to think of all the factors of 24. So 1 and 24, 2 and 12, what do you got? 3 and 8, 4 and 6. That's a lot of factors, right? But now that I took out that 2, the number on top is a 6. That's easier. 1 and 6, 2 and 3. And I'm not going to use anything with 1, so I got to use 2 and 3, right? So, and if you're wondering what the heck am I doing for the 6, it's because A is 2, B is 5, C is 3. Okay, so 2 times 3 is 6. 5 goes here, right? So we have 1, 6, 2, and 3. Okay, what 2 numbers am I going to use that multiply to 6 that add up to 3? Well, a 2 and a 3. Now you might say, well, 1 and 6 also work. 6 minus 1. Well, yeah, but 6 and a negative 1 multiply to negative 6, and I need it to be a positive 6. Right, so 2 and 3 are my answers for this. Do I have to divide? Well, my A term is a 2, so I got to divide. So let's divide. That becomes a positive 1, which is good. This stays a 3/2, so I'm just going to leave it like that. So I know my factors. I'm going to write x plus 1, x plus 3/2, and don't forget that 2. All I got to do is fix that 3/2 and I'm done. So 2 times x plus 1 times 2x plus 3, and that's it. Factored. There's going to be a lot of factoring. So if you're not good at factoring, practice that. Look at videos. See if you can find maybe other tricks. Maybe X method doesn't work for you and you're like, I prefer box, or maybe somebody created something else that I don't know about. You find it on YouTube and all of a sudden things start to make sense. Do some research. You guys got like a week, right? Or a little bit more than a week. No, wait. Your test is on a Monday, right? June 5th. First test in the morning. Because I learned that the seniors finals are going backwards, 7, 6, 5, 4, 3, 2, 1. But for you guys, your finals go 7 and then 1, 2, 3, 4, 5, 6. So you guys will be Monday in the morning at 8:30. Okay? On June 5th. So yeah, usually you guys would be at the very end, but they changed it up. I don't know why. Are we okay with this one? All right, let's move on. This has a special name, this factor, x squared minus 16. Anybody remember what the name is, how you factor it? A difference of two squares. Yeah, it's called the difference of two squares. And it basically says this. If you have a term that you can write out as a squared term minus another term that you can write out as a squared term, so in other words, something like this, then your factor looks like this, just a minus b, a plus b. You don't have to do X method. You could. If you want to do the X method, your b value is 0. Okay? But you don't have to do it. I just got to rewrite x squared minus 16 as something squared minus something squared. So the first part's easy. That's x squared. What do I put in the next one? What squared is 16? 4. So put that right there. Once I have that, then automatically you jump to this. And then you're done. Factored. Now, I'm just going to show this to you guys really quick, okay? I don't want to waste a lot of time on it. If you wanted to do this using the X method, A times C, it's 1 times negative 16 is negative 16. Your B value, I told you, is 0. What two numbers multiply to 16 but give you a 0 when you subtract them or add them? It would be a positive 4 and a negative 4, right? Because negative 4 times a 4 is a negative 16. 4 minus 4 is 0. So your factor would be x plus 4, x minus 4. Notice, same thing. I know they're flipped, but it's multiplication. It doesn't matter. So if you wanted to do it using the X method because you're like, I don't want to have to memorize another formula. Okay, fine. Just remember your B term is 0. There's no X term by itself. There's an X squared, there's a number, but nothing like a 5X or anything like that. So your B term is a 0. You can still do the X method and get the same answer. It's just easier if you remember the formula, but whatever works for you, it's going to be the same. All right. Factor this. Notice not solving, just factor. So what do they have in common in this case? A t, and what else? A 5. So let's take out a 5t. If I take out a 5t from 5t squared, I'm left with a t minus. And if I take out the 5t from 5t, all that's left is a 1. And you're done. This problem's finished. Are we okay with that one? Real quick, right? Last one for the day. I'm going to pause it. I'm going to give you guys a couple minutes. Okay, try it out. All right, so now that you guys had some time, let's find out what this is. Okay, so if I have to factor a trinomial, first thing I want to do is ask myself, do they have anything in common? 4, 11, and 3 do not share anything other than a 1, but you don't want to factor out a 1. That's a waste of time. And then they don't all have the letter K, so there's nothing I can do with them. Okay, so at this point, I am just going to start factoring. So my A is a 4, my B is an 11, and my C is a negative 3. A times C is negative 12, that goes on top. B is 11, that goes on the bottom. I got to think of two numbers that multiply to 12 that give me a negative 11. I would say 12 and 1, right? And one of them has to be negative. So positive 12 minus 1. That gives me what I need. Now, since A is 4, I got to divide everything by 4. The negative 1/4 is good, but the 12 over 4 is a positive 3, so there's a plus 3 there, and a negative 1/4 there. Okay, remember, if they were to say solve, your answers are right there in circles, right? We just saw that last time. They're actually right there, okay? But they're not asking me to solve. They just want me to factor. So, K plus 3, K, minus a quarter. Now, I don't want that 1/4, right? So I'm going to get the 4 and move it towards the front of the K. So that's K plus 3, 4K minus 1, and that's it. All right? So we'll stop here.